Welcome to this explainer. Today, we're popping the hood to demystify the absolute mechanical magic happening right inside your car's engine. If you've ever wondered how modern engines manage to squeeze out, just massive performance while still getting incredible gas mileage, well, you are in the right place. We're going to break down exactly how variable valve timing, or VVT, totally transforms the way an engine breathes.
So, why do some engines roar at high speeds but just kind of choke at a red light? Let's dive right into the physical problem of fixed valve timing. Think about it. When you're sprinting, you breathe very differently than when you're just chilling on the couch, right? An engine is exactly the same way. But for decades, engines were stuck breathing at just one rigid rhythm, totally regardless of how fast they were actually running.
Here's our roadmap for today's explainer. We'll start with a fixed timing compromise, cover what exactly VVT is, look at its physical anatomy, walk through the step-by-step process, see how it actually adapts to your drive, and finally, wrap up with why your oil absolutely matters.
All right, Section 1, the fixed timing compromise. This is the fundamental flaw of traditional engines, and we'll see exactly why this rigid design forces engine builders into a massive compromise.
The crucial thing to wrap your head around here is that air actually has mass and momentum. When an engine is running at high speeds, it has literally fractions of a second to pull fresh air in and push the burned exhaust gas out. To help this rushing air keep its momentum, engineers use something called valve overlap. That's when the intake valve actually starts opening before the exhaust valve has completely closed. It's awesome for breathing at high RPMs, but at low speeds, like idling at a stoplight, that exact same overlap causes exhaust gases to flow backward, and that gives you a super rough idle and just terrible performance.
This bicycle analogy hits the nail on the head. A traditional engine is kind of like a bike stuck in a single gear. If that gear is great for cruising, it's going to be a nightmare for starting from a dead stop. In an engine, if the camshaft opens the quote-unquote door for the air at the exact same millisecond every single time, you get one optimized speed and a compromise everywhere else. Variable timing, though, gives us the power to tell that door to open a little earlier or a little later, entirely depending on what the engine actually needs right then and there. Moving on to Section 2, what exactly is VVT? It's honestly the ultimate mechanical hack, stepping in as the hero that totally solves our engine's breathing problem. This quote gets right to the heart of the whole concept. VVT changes the phase relationship relative to the crankshaft. Now think about that for a second. The actual physical lobes on the camshaft, they don't magically change shape. They just act at a different time. The crankshaft is tracking where the pistons are, and the camshaft decides when the valves open. VVT simply shifts that relationship. It turns a rigid, locked-in mechanical connection into something incredibly flexible. Now, to really grasp this system, we have to contrast the terms advance and retard. And hey, it's not simply sliding the camshaft left or right. It's all about the clock. When the system advances the camshaft, it's telling the valves to open and close earlier in the piston cycle. When it retards the camshaft, it delays those events, making them happen later. The whole shebang is just about shifting the schedule of events. Okay, let's clear up a super common misconception right off the bat, because these two acronyms get mixed up constantly. Changing when a valve opens is entirely different from changing how far it opens. Variable valve timing, VVT, is strictly about the clock, when the event actually happens. Variable valve lift, or VVL, that's about the physical distance the valve actually drops down into the cylinder. Now, sure, some wild modern engines combine both, but for this explainer, we're focusing purely on mastering that timing. All right, Section 3, Anatomy of the VVT. This is where electronics, hydraulics, and mechanics meet. Let's look at the physical parts making up this elegant trio. So here's our starting lineup. We kick things off with the ECU, that's the engine's electronic brain, which pulls data from the position sensors. Then we've got the VVT solenoid, essentially an electrically controlled valve. But here's the real kicker, engine oil. In a VVT system, oil isn't just some lubricant keeping the metal from wearing down. No way. It's an active, high-pressure hydraulic working fluid. It's literally used to physically push the final component, the cam phaser, which is what actually rotates the camshaft. Up next, Section 4, the step-by-step process. Let's trace the journey of a digital command from the brain as it transforms into physical hydraulic motion. What's so absolutely incredible here is how hydraulic oil pressure actively forces that cam phaser to rotate the camshaft in this continuous closed-loop cycle.
It starts with the sensors reading the engine's load and speed. The ECU crunches those numbers, calculates the perfect timing, and zaps the VVT solenoid with a digital command. The solenoid pops open, channeling pressurized engine oil straight into specific chambers inside the cam phaser. That hydraulic force literally twists the camshaft slightly forward or backward. Finally, and this is what makes it such a smart system, the sensors verify the new position and report right back to the ECU. It's adjusting constantly. We're talking thousands of times every single minute.
Let's jump into Section 5, Adapting to the Drive, Real-Time Engine Strategies. Let's see how these parts dynamically react to what you're doing behind the wheel, because VVT is way more than just a basic on and off switch. This real-time flexibility is exactly what makes VVT a total game changer. It's optimizing everything from idle stability to high-speed breathing, moment by moment. Picture this. You're sitting at a stoplight, low RPM. The system steps in and minimizes valve overlap to guarantee a smooth, stable idle. But then, you stomp on the gas to accelerate, right? The system dynamically shifts that timing to maximize cylinder filling, giving you a massive surge of torque. And when you're just flying down the highway at high RPMs, it adopts aggressive timing to take full advantage of the momentum from all that fast-moving air. Now, while simpler systems might only tweak the intake camshaft, dual VVT gives the engine's computer an even greater level of mastery. By physically manipulating both the intake and the exhaust camshafts completely independently, the engine can dial in the exact microscopic amount of valve overlap needed for that specific millisecond of driving. It's honestly like conducting a symphony where you control every single instrument perfectly.
And finally, Section 6, Why Your Oil Matters, the lifeblood of the VVT system. Let's bring this highly advanced mechanical marvel right back down to earth, straight into your driveway. Look, if you neglect your oil, this beautiful, intricate balance of electronics and hydraulics just breaks down entirely. Remember, the oil passages inside that VVT solenoid and the cam phaser, they're incredibly tiny. If your oil is dirty, low, or even just the wrong viscosity, it restricts the flow. And the result? You're gonna experience a rough idle, hesitation when you try to accelerate, a glowing check engine light, and quite often, a really distinct rattling noise from the timing area. Why? Because the phaser just doesn't have the hydraulic pressure it needs to hold its physical position. This perfectly summarizes both the brilliance and the vulnerability of the whole setup. VVT is a tight-knit combination of electronics, hydraulics, and mechanical timing. Because your engine oil is the actual hydraulic fluid physically pushing these heavy mechanical parts around, having clean oil at the absolute correct pressure is 100% non-negotiable. Seriously, you can have the smartest ECU in the world, but if the hydraulic fluid is compromised, the mechanics simply cannot do their job. So we'll end on this thought. This brilliant mechanical hack, this incredible symphony of sensors, solenoids, and shifting camshafts, well, it only works if you do your part in the garage. Your engine changes its physical mechanics thousands of times a minute to optimize your power and fuel economy. So ask yourself, when was the last time you changed its oil? Take care of its lifeblood and it'll take care of you on the road. Thanks for joining me on this explainer, and keep that curiosity revving.